we are live. Yeah, I see in chat we are a go. Cool. I'm Mike. I appreciate everyone joining me today. Let me just jump to the next slide here. I'm going to be bouncing around, so I'm not going to go full screen. I think this will actually be easier for me. If anything is unreadable, please shout in the chat. So for anyone who missed our conversations yesterday, we kicked off talking about knowledge graphs. It was a really exciting opportunity to, I think, talk to a lot of people for the first time about knowledge graphs. And then we had another session in the afternoon. I had the ability to be a part of a panel and give some perspective from the industry and about knowledge graphs. So I want to start off, I think a lot of you hopefully attended those, but just to recap some of the key points. But I do want this to be potentially interactive. I know it's tricky when folks can't answer questions. I'm trying to monitor the question and asking, trying to monitor the chat as well. So please shout. I'm happy to be interrupted. This session can go any way any of the attendees want. Excited to be very flexible with everyone. If you would like to follow along at home, so these are the instructions to get you started. So you can go to cloud.stardog.com right now, create your Stardog Cloud account. It's free to get started. The demo, part of the demo I showed from yesterday, the Star Wars part, is available. You don't have to get anything. The details are here, and I'll show you how to get into this in just a second. I hope to get to basically recreating that demo. The kind of pre-canned version of it is read-only. So if you actually want to follow along and actually build a knowledge graph along with me today, you're going to have to go ahead and grab your own Stardog. You can see this big green button, get a Stardog Cloud instance, and that'll give you a couple different options for creating your own knowledge graph. So let's just walk through that super quick. When you get into clouds.stardog.com, you will come here to the homepage. You'll see this port be empty because you probably don't have any connections. So you can just push the new connection button here. This is anonymous, the express URL, and then you can call it express so you can get back to it later. If you want to play along at home, that's just get a Stardog instance. You can get free or you can get essentials and go ahead and get yourself something that you can play around with more completely. So I will go back to that just before we get into some of the hands-on part, but I do want to jump back over the slides and do a quick recap from yesterday. I should check, make sure there's no questions. Oh, yes, thank you. There's also a poll, so would love to know. Got 8 votes so far for somewhat on knowledge graph, so this will be a good overview for folks. The key about knowledge graphs is they're based on these 3 pillars, and ultimately what knowledge graphs, enterprise knowledge graphs, are trying to do in the enterprise is break down all the silos that exist between all the places and ways that we store data in an organization. That is call this the garbage in, garbage out problem a lot. You'll see this referred to. This is one of the things that Stardog helps with. We can provide more complete, more timely, more comprehensive, more accurate data by reaching data at the source and giving you a lot of options for avoiding making copies of data and really growing out the scope of what you can access to encompass something close to all of the relevant information. And that's why virtualization is kind of the first pillar that enterprise knowledge graphs are based on. Yes, we can absolutely make sure these slides are made available. You can, I don't know if the conference will make them available. If not through the conference, I'm happy to provide them to anyone who asks. It's just Microsoft on Twitter, or you can hit me up on LinkedIn. Oh, and that's, I think Amelia saying, yes, we will. So thank you, folks. So back to virtualization, key pillar of the semantic platform or knowledge graph platform, bring together all that data all in one place, stop making copies. But we're not bringing it together in native data models because you have lots of different models. You have SQL, NoSQL, and then even within those different flavors, there's a lot of differences between Postgres and Oracle, Mongo and Cassandra. So we link all that together, we unify it with a graph. Graph becomes our kind of fundamental data model for bringing all these things together. The semantic graph, then we're overlaying actual precise business meaning on that data, and it goes with the data. As we talked about yesterday, this is very different from most approaches where the meaning is ascribed to data completely ad hoc. It's done more often than not entirely separately in a catalog or glossary or dictionary or some artifact of that type. It's also done a lot in code, which presents its own set of challenges. The semantic graph moves it out of those two places where it should not be and moves it into the data where it ought to be. This gives you this really wonderful corpus of information. It gives you a way to more precisely define it. And then the inference engine we'll actually look at a little bit in more depth later on, time permitting, takes all that precise knowledge and starts filling in the gaps. So you can have even more precise business logic in the form of very simple if-then rules that lets you plug those gaps, find new connections, shorten paths between related nodes. It's a really powerful way to connect the graph. It's also a way to provide different views and different ways of slicing and dicing the graph. One of the things we learn from master data management and a challenge with these data silos is they become very fit for purpose. They get locked into the one and only one way to define something like a customer. And there's no singular definition for what a customer is in this example, or why that data is important. Depending on who you are, what you're trying to accomplish, you may take away or may require different aspects of a particular resource in your universe. So the inference engine is a really powerful way to let you slice and dice the graph in any way that makes sense for you for your use case. It's all dynamic. They can live, you have many of them, they can be contradictory, people can be using multiple ones at the same time. So very different from your traditional databases where you're kind of locked into the one and only one way that data presents itself. Come too far. So we've wrapped these kind of main pillars in this simple process. We're an engineering founded company. We think about building knowledge graphs in a very simple and iterative fashion. The technology is made to support starting small, moving quickly, making progress in bite-sized chunks. It is pretty much the opposite of a lot of the big data, big operational overhead actions that we have today, where we need teams of people, we need whole data centers worth of hardware to go ahead and be able to stand up a new source. This works with everything you've already stood up. We're just overlaying right on top of what you've got. That's another reason why virtualization is so key. It lets you move very quickly and adapt to changing requirements, because requirements, they change sometimes. And when you don't have to re-ETL things, make new copies to support a new requirement, you can just amend the data model, add new inferences, create an entirely new model to look at that data. You can be much more responsive to what the business needs. Yes, you can apply Graphml on knowledge graphs. Actually, here, let's just jump ahead to the next slide. It's a great question. We kind of put that as one of the native capabilities within the knowledge graphs in this compute layer here in the middle. So data modeling sets that semantic layer we were just talking about, the inference engine, inferencing, again, we were just talking about, and then machine learning to the question. We absolutely see that as part of this middle part of the platform, because a lot of the challenges when you're doing analytics is, what do you do with what you've learned? Now you have a whole other operational hassle. How do we get that wherever it needs to go so that someone else can use it? And the goal for the enterprise knowledge graph is that everything worth using is there and easily used by anyone in the organization. This is what the access layer is for, to bubble that up to all the tools the organization's already using and make all the rich world of information that's in the knowledge graph available to everyone who's interested in it. So the Stardog platform has a number of options for doing machine learning natively within our platform, but you can also layer stuff on top. We have a Python API, so very friendly for data scientists to just work with Stardog as they would anything else and build on top rather than have to leverage what's built in the middle. That was all the time I had allotted on my recap. Let's see, let's check in on this poll. I'm still trending towards not a lot of people familiar with knowledge graphs, so that's exciting. Unless people have questions, and again, I'm monitoring all this, I'm going to go ahead and jump into the demo. Hopefully that will codify or clarify some of these things, and then we'll actually jump into recreating it and give people an idea for what this would be like to move through one of those cycles in one of those sprints that I was just talking about. So just as a reminder, in case anyone's just joining late, cloud.stardog.com. You can use Express here. This is the URL that you will need. Login is anonymous if you want to go ahead and play along at home. You can grab your own database to use for the kind of the second half of this workshop. So here I'm coming over to Stardog Cloud. I was going to focus just on the Star Wars demo, but I just wanted to jump back to part of what I showed yesterday, just because we had the question in chat earlier about machine learning. And I'm seeing a new question. Yes, Graph works with data virtualization. Data does not need to be centralized in one place. That's precisely the point of having the virtualization layer, so you don't have to centralize or consolidate data all in one place. So we'll go into Explore just to help answer the question about what the ML looks like from the knowledge graph perspective. So I've already got something where I've done the work. I'll go a long way to get into this. So I'm just searching through, this is a healthcare life sciences data set. This is put together from a number of public sources. So this is all open data that you're able to get to. I can look here, ct.gov, NCBI. It's where we got the data specifically about this concept from. But to the question around machine learning, like I said, the goal is to have this stuff back in the knowledge graph. If it's not in the knowledge graph, then you can't use it. And that's really what we're going for, just make everything available. So I have this particular drug, it's in this gray node, it's connected component. So I ran graph analytics. The connected component that was calculated just comes back into the knowledge graph. It's queryable like anything else. So I don't have to go some other place to see the results. I'm just taking data from my knowledge graph, running it through the algorithm. The results of the algorithm are now a part of the knowledge graph. It's treated as kind of like one of the indices of a database. The other similar example, problems clicking today. Unfortunately, shared for everyone to see. Another example we had that we went through yesterday, this fellow Bob Stiles, insurance use case. He owns this home, and we use comparables to be able to predict this insurance premium of $4,087. Again, it's just data in the knowledge graph. It needn't be separate. When it's separate, it's harder to use. So knowledge graph is about bringing everything together and breaking down these distinctions and separations that we may make for operational reasons, oftentimes for good operational reasons, but we need to make this data available to everyone and take out the pain of putting data together, which is still arguably the number one pain point and the number one reason why people struggle to get the most value out of data, because it's hard to get all the right data in the right formats, have it be consistent, all those, we've heard of these challenges. Well, hopefully we didn't lose my audio. I see someone asking a question, but I see my video is still working, so I'm going to keep on trucking here. So we've got the, now I'm going to go over to this KGC demo, actually, database. I'm going to go in Designer. So you can see the lay of the land. This is the full project. This is what I created and what we'll go over. And then we're going to recreate a good chunk of this together. We'll see how it goes with people only being able to ask questions via chat. It'll be a little trickier than I was hoping. But this is kind of what we've done. To the person who asked about virtualization, in this simple example, we're just using, I've got a CSV here, here, and here, and it's just 3 static sources. It's a demo. But if I go back out to Designer, just to show Actually, here, I'll just create a new project so everyone can see what the experience looks like for creating a relational source. I'm connected to the company server here. I want to use Databricks. So I've got a number of Databricks databases and tables that are available to me. I can go ahead and pick this one. And there's a trips database in here. So I can go ahead and pick that. I get a preview of the table. Trips. Now it's available. I haven't moved the data. It's about to be a part of my knowledge graph. What happens next, we'll show in a little bit, but it's that easy to get relational data into Stardog. And then I'm not moving it, so Stardog is just going to query that same Databricks database that I just set up that corresponds to this trips resource. I go back over to the demo here. Ling, that's a great question. I'm going to try and put a pin into that one because we're going to show a little bit of that in a second here. I go back over, and this is the question that was just asked in chat. Basically, what do you do with mediocre data? So we have data here where we've got NA, we've got /NA, and we're using NA interchangeably instead of null or blank. We've got things with units that don't make any sense. That's kilometers in a speed column. Everything is a string here. So a lot of challenges in micro that we see with enterprise data and macro. So if we go over here into our database, we can see we've got the same data model here in Explorer. So shows the same view, but let's jump to something that's got some of that not optimal data. So the proverbial Star Destroyer. Here we can go ahead and look at it, and we see what we saw in that spreadsheet, except we've converted over to graph. These are just strings. More strings. Manufacturer, this ought to be a node, but it's a string. So how do we do this? Normally, what are we going to do? We're going to make a copy, and we're going to modify it ourselves. We don't have to do that with knowledge graphs. We can let, particularly that Inference Engine, handle a lot of that work for us. It can also be done when we do the mappings, but I prefer to let it happen in the inferencing layer. So what I've done is I've made some simple rules and call this the clean version of the data, and then I'm going to go ahead and toggle on the Inference Engine. So you're going to see two things happen. The first is immediately noticeable. You're going to see there's kind of different colors on stuff. So we've categorized things differently. There's concepts like things with fast hyperdrives. Ships don't declare they have a fast hyperdrive. They have a hyperdrive. And then I've written some business logic to define what I think a fast one is. Someone else could have their own definition, and we could have different sets of ships that have fast hyperdrives because we have different determinations on that. That's why you see kind of the different classifications here. And then if we go back into this resource, capacity, that was my original data. I've left it here as a string for comparison. And I know Explorer makes it a little hard to see, but cargo capacity here, this is actually, it's a typed, it's numeric, it's cubic meters. Come down here, same thing with length and length of ship. Manufacturer, again, I left this string, but here I've uplifted it from a string to a node. And this is where you start seeing some really cool stuff going on, because it's a very simple process where I uplifted it, but now I'm able to work through the graph. I've got a more connected set of data than I had when it was simply flat and just kind of transferred over to the graph. I've made it more rich with that just slightly more precise definition. And this is what that semantic layer is all about, providing those crisper, more complete definitions of all the concepts that you care about. And then what we're able to do is, so we saw the base, and the Rebel Alliance just kind of extends from this. So we're going to see a very similar thing here. Really, the only real difference is the Rebels use different credits. So you can see this is the base cost in Imperial credits. This is the cost in Rebel credits. I guess they're called. I don't know what they're called. I made it up. But just to show this happens automatically, I didn't change any of this data. Similarly, I can go to look at Empire. Now the money's gonna, we don't need to change that, but the Empire, they're quirky. They use the Imperial system for measurements. So you see the ship classifications change because they've got a whole different scheme. These two things, again, side by side, living simultaneously. They do not agree. They're over the same data. This is all happening dynamically. This is one of the powerful things about knowledge graphs. So now if I look at Star Destroyer here, I can see cargo capacity. This is in cubic feet. And down here, length of ship, this is in feet and not meters. Still the same uplift though from strings to things here. I've got this, what was a string, turned appropriately into nodes in the graph so that I can move around and connect to this data and begin to have a more complete picture of what's going on. Inference rules are deductive, yes. If you've got background, it's basically data log. If you don't have background in logics, if then, we'll see one in a little bit. But it's pretty straightforward to create these things. If no one believes me, we're going to go ahead and do that, and then you can determine for yourselves whether or not you think it looks hard or not. So I just grabbed these CSVs from Kaggle. You are welcome to grab them yourself if you would like to play along, but that's what I'm going to use here. So I'm going to close out that designer project. And then this is just Joe Young, Star Wars Kaggle, if you want to go grab it. So here we are. I'm going to go into designer and workshop. So got a blank slate. Let's go ahead and, so I showed a moment ago, project resource over here, virtual graph using a relational system. Now we're going to use a CSV, just I think it's easier for all of us. Let's just start with planets. That's an easy one. So here we get a quick preview of the data that we're interested in bringing in, and yep, I'm interested in that. If data is not yet in the knowledge graph, we've added to our canvas. So we have a file, but we don't have any concepts. We don't have anything to talk about. We need to start creating that semantic layer. So I'm going to go ahead and create the planet class. So now I've got planet class and some planet data. So I need to connect the two of these. Go ahead and select my source, planet mapping. Of course, that's being a little finicky. There. So now all I'm doing is I'm drawing correspondences. I'm not writing any code. I don't have to fuss with rules or queries or anything like that. This is very simple. So again, if I ever need to go back and remind myself what this looks like, it's easily accessible from the top menu. So name looked like it was both a primary identifier and a label. You see that planet turned blue. So I've kind of got the minimum I need to go ahead and publish this data into my knowledge graph. But there's more data in there that I want to bring into the knowledge graph, but I don't have anything to select here. So I've got my planet class over here, and I can just look. So we've got climate, diameter, gravity, planet's got a name. All right, and we can go through it and do all these things, but I'm not going to take that time. But once I've created them, see they're immediately available over here, and go ahead and select all of these out. That all looks pretty good to me. So now I want to publish and go into Stardog Studio here. Stardog Studio is our IDE. This is kind of the admin interface. You'll eventually be able to create databases directly from Designer, but for now, this is the right way to go. So DSC workshop, I'm going to create a new database. That'll take a second here. Cool. Funky. Just refresh that. All right. Go back to that database I just created. And then one thing you want to do, two properties you want to set. You search for search. You want to enable search. The database is currently online. You want to toggle it off right here at the top. Go ahead, enable search. and then we'll look for alias, and we're going to turn on name graph aliases. There are two good defaults if you're using Stardog. I tend to always turn both of those on for all databases that I create. I found them to be very useful. So I can go ahead and save those properties, bring that back online. We are all set. And jump back over to Designer. Now, this publish button at the top, go ahead and server. This is where you'll need your own if you're playing along at home. So I'm just using our central server, and then go to that workshop database that I just created. Go ahead and hit publish here. Cool. It's there. So now I can go into Explorer. And select my workshop. You see here, there's planet, my one concept I've created. I can visualize my data model, and I get the one thing, planet, that I created. But then I can go ahead and see all instances of planet. Here's the 61 things that were in that spreadsheet, and just pull out one of them, take a look. It looks like what I was going for, so great. Got that data over. Someone asked about certificate for participation. I don't know that I can help with that. So that's our first data source that we've gotten into our knowledge graph. So let's go back over to Designer and start bringing in some more data. Go ahead and grab the next file, characters. So where things start getting interesting. So data, all the suspects, usual suspects, there's Luke right there at the top. But kind of fun here, we've homeworld, so these are planets. So now we need to connect these two data sources together. So I'll show you how we're going to do that to get these things to link up. Go ahead. Very kind of similar scheme here. I create my character class. I'm going to go ahead and there we go. I got character mapping. I've got character class. Again, I've got nothing here. Just pull over some of these. We'll say name. They need a name. Looks like species is going to be another mapping to another table, so we'll leave that one for later. We won't do that. How about just mass and height for right now? So height, mass, and name. And we know name is identifier and a good label. So we've got characters, but we still don't have a connection from the characters to their home world. So what we want to do is we want to create a home world concept from character, to planet. So now we've created that relationship in our data model, but our data still doesn't reflect it. So we need to create one more mapping. Oops. All right. Do that all the time when I don't have the right thing selected. Homeworld mapping. So I can go ahead and take that right to the relationship. It knows how to create kind of the one end of the relationship, character, and then planet here was that home world record in that spreadsheet, or you can think of these things as tables as well. So now I've got that relationship between characters and their home worlds, in addition to a few basic attributes about characters themselves. So I want to see what that looks like, make sure I got everything correct. What I like to do, here's Studio. I'm going to go ahead and I tend to clear out. So I'm going to go ahead and delete the previous thing that I just published. You don't have to do this. I think it's a little bit easier for me to delete it. Here, I'll put this query right in chat. Don't be careful running that. for anyone who wants. Oh yes, those are the ones from Kaggle. For whomever asked that. Wow, there's a lot of questions. All right, so let's see how this publication goes, and then we'll jump back over and go through the questions. So my database is clear. Oops, wrong thing. Designer. So we'll go ahead and publish this back. And workshop. And to Explorer, and we'll reload Explorer just so it can pick up the changes. And now we see character is related to homeworld, related to planet via the homeworld property. That's what we were expecting to see. We should see some characters in there. Excellent, we do. So we go ahead and Wicket. We can see Wicket's homeworld is Endor. And if we expand them out, Endor is a planet. So great, we have made that kind of two-step connection, linked those two sources together, so now I'm able to query Wicket and get his homeworld as if those two sources were in the same place. Now, we've done this with CSVs. I realize that's not super exciting, but the same principles apply for any other system that Stardog can talk to. So if this had been two different tables in Databricks, all the same things would happen. And the great thing is, for me, from my perspective as the user, I don't know if they're CSVs, I don't know if it's Databricks, I don't know if it's Oracle, I have no idea. It doesn't matter. That's the point. Now let's jump over an architect. So let me just read the question. Can I simplify the concept of knowledge graph and say at first step, this is a better way to design data architecture while avoiding or discarding the SQL, NoSQL, and other type of databases and optimize them for use? Yes. I think it was maybe part of the point I just made is part of the answer to your question. Those are all good systems, whatever SQL or NoSQL system you have in mind, but they should be used in the specific cases where they're very good systems. So yeah, use the right operational tool for the job. What Enterprise Knowledge Graph does give you is that design for a better data architecture that isolates or abstracts you away from those implementation details of how individual units of data are stored and provide a capability to the enterprise to get all relevant data, regardless of where or how it's stored, using concepts like character and planet and spacecraft, which we're about to do, and not keys and values, rows and columns. Oh, thank you for whomever put the link into the data sets. Appreciate that. All right, so let's jump back over and keep on going here. So we'll bring in the next data source. Let's do Starships. This is where I think things start getting kind of fun. So this is that same resource that I showed earlier in the demo. So we can see the same kind of messy data. So we'll be able to deal with that ourselves here in a bit and see how that actually happens. But for now, we're just going to take it as is. Great. So we'll go these spacecraft. Got another concept here. Go ahead and select our data, and we want to another mapping, and there, we've got spacecraft. And similarly, we got to create some properties for it. Capacity, cost in credits. We've got a length here. Maybe we'll stick with that for now. Oh, how about model? And hyperdrive rating. Cool. So there's a base set of properties. We'll go ahead and pick these: length, hyperdrive rating, cost and credits, and capacity. And name again, spacecraft is blue. Got a complete mapping here. That looks pretty good. So I'm going to go ahead and publish it and just double check. If I go back to Studio, I want to clear out what I was doing before. I'm going to republish. And you know, I talked earlier about how you can do this iteratively. Hopefully this is driving home that point where just cycling through and slowly building out my knowledge graph one column at a time, one source at a time. This is pretty quick and easy. You can do one column and one source and declare victory. You don't have to map every single element of every single source everywhere to get started. You can do just a handful. So we've got that data published. And now we'll go back over to Explorer. Should now see a slightly more complicated data model. We've got spacecraft, excellent, and I should see that I've got spacecraft now. That's cool. That's more data. We'll come back to cleaning up that spacecraft data at the end because I just want to show a couple of other things that go on here. I want to add one more thing. This gets down to remodeling. So these are landcraft versus spacecraft, but that file looks pretty similar. Go back to it. I think I might have been too quick. We've got model, we've got manufacturer, we've got cost and credits, we've got length, we've got cargo capacity. So, okay, and that's cool. There's some things that we can reuse, right? We have those concepts. So let's create a vehicle concept. And go ahead and usual. It's going to be a little different this time. We don't have to create anything. We've got capacity, we've got cost, we've got model, we've got length, and vehicle has a name. Cost, length, and vehicle name. That all looks good to me. Let's republish and take a look. I also want to start getting into the reasoner. We talked about that, and we haven't gotten SIA yet. So we've got Doghouse, my server. So, republish here. Just to answer John's question real quick, yes, Stardog supports all of the semantic web standards for ontologies. So the full acronym soup of the semantic web, RDF, OWL, Swirl, all that stuff. And that's not Stardog technology. That's not Stardog specific things. Those were created by the W3C. That's just specifications that we choose to implement, much like SQL, that are not governed by us. So publication is done. So we can pop over here and we'll see a fourth concept, vehicle and spacecraft. That's excellent. So I can take a look at one of these vehicles, a sand crawler. What happens if I turn on the Inference Engine here? Make sure I select. Okay, well, that's weird. So the Inference Engine is telling me that a sand crawler is a spacecraft and a vehicle. It's not. There's a free cloud version for the person who's asking. So Stardog is free. There's also a free downloadable version that's not linked through cloud.stardog.com. You get that from our homepage at stardog.com. But Sandcrawler, why is it both of these things? Well, to save you the debugging, it's because if we go back over to the designer, we use some of spacecraft's properties on our vehicle. So it seemed helpful, right? Because we were avoiding some of the work of creating new stuff. We wanted to leverage our existing investment, but we used properties that were previously associated with a different concept. So the reasoner's trying to be helpful and saying, hey, well, you use spacecraft properties, so that thing must be a spacecraft. That's not really what we meant. What we meant was there's a thing that spacecraft and vehicles are that has these common properties. So let's call that a craft. So I'm going to say now craft has two children, spacecraft and vehicle. And I'm going to just link these things. Because they all belong to craft. Cost, capacity, model, more, and length. There we go. So those are my four common properties that I want to put on craft. And now spacecraft, I'm going to go back through and reselect those. But what's happening here is I'm able to remodel and change this on the fly. And as I make these changes, I'm going to be able to go back here and I will see things stop being either spacecraft or vehicle, or stop seeing things be both spacecraft and vehicle, which is really cool. But let's not worry about that so much right now. Hopefully no one's hearing my doorbell going off right now. Apologize, I should have put my phone on mute. Okay, let's back out of those changes, just because I don't want to go too far down that hole just with time. So this is just back to where we were, to where we had just previously published. We can do that additional file here. We've got species. We can set it up. It's going to look the same as this setup, right? So there's some species in here, and characters were species. So, you know, we need a species class, and you guys kind of know that drill, that we were able to go through and get those things to line up. But I wanted to go back to what we were talking about, is cleaning up some of this data. Turn off the reasoner for a second. And we just look at the star destroy. Oh, shouldn't have dismissed it. Details. So, you know, here's our string properties. In particular, let's just focus on this length and get this turned into an actual number rather than a string. Okay, so if I go over to Studio here, and this is where a lot of this stuff that happens in Studio right now, we're going to be pushing into Designer, particularly the rule creation. Right now it's a bit low level, but I know this is a quite technical audience, so this should still feel pretty comfortable. So I can go ahead and see all the graphs that I have in my data set here. This is where I'm storing my data model here at the top, and then I have generated graphs for each of those data sets. So this is where I want to put my rules, because that's where my data model goes. So I'm going to just remember that for a second. But I want to query my data because I want to try this out first, right? I want to see what's going on, and I want to query my data. And let's see, what do we have in here that's a let me get the right thing here. Concept class, and let's see, with spacecraft, right? So it should give us all of our spacecraft. Well, should have. So we didn't get the IRI right, so it's an easy thing. So what are all the classes? I can see here. Just go ahead and grab that. and now I can see all of the spacecraft. So I want to get spacecraft and the length. So for any of you who work commonly with SQL, hopefully this is starting to feel like working with SQL in a SQL editor. So again, what was that property called? It's pretty easy for me to get all the properties. I'll go ahead and do that. And I can see in length here. So great. So I can see all my spacecraft and all of their lengths. For the most part, they're numbers, except for the one case that we were looking at, Star Destroyers. They're a little quirky. They're the only thing that has a comma. There are other values that are in the thousands that do not. So kind of want to scrub that out before we try and transform it into a number, because it's actually going to trip things up. So what we'll do is just amend our query here. It's pretty straightforward for us to pull this out. And just in case there's any NAs, we also want to get rid of those as well. So that length is NA, we'll filter it, and then we're going to replace commas. And then we want to turn it into a decimal, and that'll be length. So we're going to select these out. And you can see these change from strings to numbers. Star Destroyer here is correctly 1600, the number, not 1,600, the string. So my data looks right. I've kind of done the right thing. Now I want to turn this into a rule. It's really straightforward. Go ahead and create a new tab. SRS, that's Stardog rule syntax. And I said it's if-then style. And I'm just basically going to turn that query upside down. So I'm going to show you why it would be upside down. So this is, I'm getting the results as a table. So I can take this same thing, and I want those results as a graph. So I want to construct a graph. And I want to say that S has a new property. Take the old one, and we'll call it length of ship is length. So we want to, let's look at this new graph. Of course, that didn't work because I forgot where to query. I want to query my knowledge graph. So I can see all this new data, and I can see it's all typed. So now to make it a rule, let's go back over here, and I'm just going to copy these things. Great. So this rule says anytime you ever see this pattern, that means that this edge exists in the knowledge graph. This edge won't be written to the knowledge graph. It just is kind of visible at runtime. It doesn't actually exist anywhere, but you can query it. So this will get used dynamically. So let's go back, and I forgot where our schema was, our data model. Grab that again. And go ahead and add that data to that graph. So we went ahead and added this rule to our data model. Now, if we refresh Explorer, and in here we've got our Star Destroyer. Oh, did it again. So if we look at the details, we see the raw data 1600. So we're going to go up, and we'll create a new schema in here. Oh, 3. And we're going to turn on the reasoner. So we get that kind of funky double type that we fixed, but we didn't publish. If we go ahead and look at Star Destroyer now, you see length of ship is 1600. Okay. So I didn't change any data. All we did was flip on the reasoner. It's inferred that information. So now what I can do is I can have more rules like that to clean up the rest of the data and transform it into something that's more amenable to what I'm trying to accomplish. If someone and like these rule sets are just in here. If someone doesn't like my rule set, they can pick someone else's. They can work on their own. They can take mine and fork it and make their take on it. This is all, again, applied at runtime to whatever data you're querying, and it lets you have these dynamic views. And this is how I get varying degrees of, metric versus imperial units. One of the things we showed yesterday is classifying people as enemies depending on which schema that you use. So somewhat subjective measurements, good and bad customers, can be encoded in these rule sets as well. There's a lot of flexibility you get, and it all happens at runtime over systems that have no notion of rules. So you're able to apply this to data that's coming from both Mongo and Databricks and infer stuff as if those two sources were one, all physically in the same place. Thank you for whomever said that is clever. That was a while ago, though. I don't know what we did that was not clever. So that's kind of as much as I wanted to take through folks building today. You can go through the exercise of connecting up species yourself. As I said, it'll look like this setup here, where you can eventually get to, with just those data sets, I go back, this is kind of the final product. So you can see here, this is that craft class that we created. Here's vehicle and spacecraft. Spacecraft's got that one property left hyperdrive rating that doesn't make any sense. You can see some pretty sophisticated mapping over here around this character spreadsheet because it maps actually to multiple different concepts and multiple different relationships. All of these things all come together very neatly in what we saw before. And then again, if we go over to the final product, you have this very sophisticated data set, and then lets you do kind of these really cool queries that are driven by that semantic layer that you've built on top. So when I select something here, like concept of a pilot, I get some generic stuff because pilots are people, and so they can appear in movies with other people in the Star Wars universe. They have home planets, they have friends. So you see kind of their base things, but you can also see things that are specific to them. So the pilots have piloted, and then the notion of pilots is a spacecraft can have multiple different pilots at different times, such as the Millennium Falcon. But now I can say things about who's piloted crafts with fast hyperdrives, right? So this is my virtual concept. This is something I defined in a rule. It doesn't exist in the data. And of course, I don't have the reasoner on or any of the appropriate setup in order for that to work. But this is going to come back and tell me all the ships with fast hyperdrives, A-Wing, X-Wing, Advance, Millennium Falcon, and Y-Wing here together, and then kind of their relations in the graph, how all these things come together, so I can see, those pilots that piloted those ships in the same view as the ships they piloted. It gives me more complete context and understanding of what's going on. So I just want to jump back over to slides, pose a couple questions for folks. We're not going to go through these. I might have helped answer that last one just moments ago, so we'll see if people can get these, but you should be able to pretty easily answer these from the data set in Express. I encourage you guys all to try if you're curious, see if you can recreate the answer on your own, maybe with your own data. That would be awesome. I would love to know if folks are successful with this. If you want to tweet at me or send me messages on LinkedIn. John, yes, the rules chain together. It's all backwards chaining. So what I do, let's go back over to the demo, John, just so you can see an example of that real quick. I go over to my Star Destroyer concept. So my Star Destroyer concept, John, I'm using one rule to correctly uplift the length of ship to a numeric so that I can then use it in a different rule to infer that based on its size, it's a capital ship. So you can absolutely have rules chained together. There's some limitations around cycles, but otherwise it's a very flexible system. And we did building the demo. I will kind of wrap up on this, but as people have questions, I'm also happy to answer them. We talked a lot about in the last 2 days around how knowledge graphs can be the future of data management, and I think they're the future because of their strong lean towards solving data integration challenges, and that's ultimately what a lot of what our data struggles boil down to, is their data integration challenges. So knowledge graphs use semantic technology at the heart to bring together all these different data sources, virtualize them, you leave them in place, and create this more complete, comprehensive corpus of information. And hopefully it can be the springboard for lots of fun, interesting data projects for everyone here in the near future. I know that our customers, as shown here, have seen a lot of very positive results adopting this approach. I really wanted to go through from the beginning today, so everyone here, I know y'all are practitioners for the most part, could see what this is like. This really is an iterative thing. You can start with one table just in one place and just make the smallest knowledge graph that's ever existed. But just because it's small doesn't mean it's not useful. People get too overly fixated on the amount of data. Small data is important too. So go find an important problem that's got a small data set that you can solve quickly. And I guarantee knowledge graphs will give you a very interesting way to approach problems that maybe you've never thought about before. So I appreciate everyone for coming. We've got, I think, 2 minutes left. So if people have additional questions, I'm happy to answer them. The slides will be available. The recording will be available. Stardog.com, cloud.stardog.com, if you want to try this out. We have tons of resources, and really excited for all of you to get started on your own personal knowledge graph journeys. I think you'll really enjoy working with the technology. So any last questions for folks? Let's see where that poll ended up. So overwhelmingly not proficient. The majority not at all familiar with knowledge graph technology, and a handful of you also somewhat. So that's really exciting. That is a new thing. This is the fun thing about these conferences, be exposed to new technology and new ways of approaching problems. Anyone have any final questions before we sign off? I can't tell if people are leaving or not. I don't know I may be just talking to myself at this point. Hopefully y'all can edit this out. All right. Amelia confirms that y'all were at it. Well, thank you everyone again for coming and joining. It was really fun to be with everyone today, and I enjoyed giving you a tour of Stardog and of knowledge graphs. I'm Mike, and we'll talk soon. Oh, yeah, John, yeah, shortest path. You can do path queries in Sparkle, which is our native graph query language. You can then make them stored queries, and then you can call them as correlated subqueries. So you can get very sophisticated queries that mix pathfinding, normal conjunctive query answering over virtualized data, while also using the Inference Engine to infer links along the way. And then last question, does knowledge graph work with data that doesn't have a good definition or lineage to start with? Hopefully we covered that throughout the conversation. Knowledge graphs, their flexibility, I think, is their real key for addressing challenges around somewhat less than ideal data. How does it relate to graph databases? They're both graph-based. Graph databases tend to be a reincarnation of a lot of the challenges that we see with relational systems. We end up creating silos that are graph-shaped rather than silos that are table-shaped. So we have the same problem, it's just now in a different shape. It's graph-shaped rather than relational. So that's where those traditional graph databases that Tiger Graphs or Neos or Orangos of the world, they could be very good tools for point use problems, like Postgres can, but they're poor fits for this comprehensive infrastructure, the systemic approach to doing data integration. That's not what they're built for. They're built for smaller, specific use cases. But I absolutely agree with him that graph is the right way to represent data. At Stardog, we've just chosen a more expansive view of what the graph can be. We don't believe the graph is contained only within our walls. The graph spans not only the enterprise, but the entirety of what's available to that enterprise or relevant to it. So whatever's on the internet. And with that, we are definitely out of time. Thank you, everyone. So many great questions. It was really exciting engagement, and good luck on your knowledge graph journey.